Good evening and welcome to our sixth class on finite automata on 2601, 2601, our introduction to computer science, theoretical computer science, right? So today we are going to move on. Last time we were speaking about finite automata. Today we want to move on to a different section and speak about finite automata with output, okay? But first, before we go there, we want to look at a component of finite automata called transition graph. Right. So a transition graph, we're going to see that all finite automata transition graph, but we've got another machine that accepts regular languages that is called a transition graph. So a transition graph also is a collection of three things, just as the finite automata was. Number one, we've got a finite set of states. At least one of them is designated start state. So the difference was that in a finite automata, we had only one start state. In this case, we can have multiple start states. Right. And then some, maybe none, of which are designated final states. So at least one final state and then zero or more, at least one initial state and then zero or more final states. But number two, we've got an alphabet of possible input letters from which the input strings are formed. So we have an alphabet, we are familiar with alphabet. Then number three, a finite set of transitions, age labels that show how to go from some states to others, based on the reading of the specific substrings of input letters, possibly even the null string. So we've got a whole lot of differences that we're now starting here. We're seeing that the transition can be labeled with, so if we have a transition, we can label with the letter of the alphabet, we can label with the substring, we can also label with null. Right? So you can label with any of these. Substring can be a full word, it can be a single word, it can be null. Any of these can be labels to a transition graph. And then in this case, the other difference in terms of transitions that in the finite automata for each state we needed two outgoing transitions with each letter of the alphabet. Now the possibility or now the option of giving a word as a substring as a label for the graph takes that away, right? So that is what a transition graph is. All right, so let's look at an example to demonstrate this transition graph. Right, we have got the following: build a TG that accepts the language of all strings that begin with a B, at least contain one ABA substring. Begin with a B, begin with B, at least one ABA substring. Right. Or at least, also it's or at least one AB substring. One AB substring. Right. So one AB, also it's an AB substring. Right. Use as few states as possible. So begin with a B, at least one ABA substring, or at least that. So let's start with the finite automata for that. So finite automata, begin with a B. So B, right? And after that, contain at least one ABA or at least one AB substring. So you can have A, then we can have B. This can go to a final state, or from here you can have an A. It goes to a final state as well, right? So that is a general way of doing it. Otherwise, once you have gotten AB, you could come easily to have and now an A or B over here that would still be accepted, right? So this would be accepted. So let's take this away. This is optional. Then for a finite automata, the additional instruction was that we need to specify if you encounter A at this point, go to a looping state, A or B. If you encounter B at this state, right, you can keep using the B's, they're fine, as long as you go on indefinitely B. If you encounter an A at this state, right, you can keep looping at this state, you're fine. Then if you encounter a final state, you can go through to then A or a B. So this becomes a full finite automata. A transition graph for this would be as follows. So we've got now, and with now we either get, we can have an A or B here, then have AB or ABA. Then we've got a final state within A or B, like that. So that will be the difference between a transition graph and a finite automata. Right, so this is fairly easy. We're not going to dwell much on that, so otherwise, but we're going to now move on to finite automata with output. So you can go and try some examples of this, and then you can have a look at them together. Now let's move to finite automata with output. Now with finite automata with output, so far we've been given only finite automata, right? So the finite automata only takes input and spits out so it wants to split, it only gives yes or no. That is to say, language accepted or language not accepted. That's all that it will give you. Or wait in language or wait not in language. Right, but then sometimes we need to deduce meaning input for our finite automata for them to interact with our world. So if you look at artificial intelligence, for example, they will say, get some input, processing, give some output. So the output is supposed to relay some information to whatever the environment is requesting it to do. All right. Now let's look at the following. In this, we've got two machines that we can look at. Number one, we've got a Moore machine, which is a collection of 5 things. Number one is a finite set of states. So there are states up to infinity, but Q0 represents the start state. Then an alphabet of running letters for forming the input string ABC. So we've got an alphabet of letters, an alphabet of possible outside letters. We've got X, Y, Z. Those outside letters. A transition table shows for each state in each input letter, state what what state is reached next, and an output table that shows which character from P is printed by each of the states as each of the states is entered. Right. Now, those are the properties of a Moore machine. Let's see them in action. So here we do not have an initial state, we do not have a final state. Right. So let's look at the following Moore machine. Let's put this machine into the put input to this machine to be A, B, A, B, B, B. Right. So say you enter. So we say if you are sitting on a Moore machine, this is what will happen. Number one, we've got let's take this up a little bit. We've got the current state that you are in. So it's input, sorry, not state, input. Then next we've got state, and then we've got output. Right? So initially we do not have an input, so it's empty. Right? But if it is empty, we start in a state somewhere. So we start at Q0, which is represented by this. This arrow represents the start state. So we're starting at Q0, and then the output there is equals to 0. Next, we get with our input is A, B, A, B, B, B. If we read an A, from Q0 you go to Q1. If you read a B, you go from Q0 to Q2. B, when you move from Q1 to B, go to Q21. Q21, right? When you go to, so this is Q1 with an A, and so you go to Q11. So when you have a B, if you have an A and you're there, you go to Q11. If you have a B and you are there, B and you're in Q1, Q21. A, that gives us Q1, 1. Then B, after an A, right, you're sitting here with a B, go to Q21. Then if you're sitting Q2 to B in Q21, then A, you go to Q0. B Q21, then A, go to Q0. Now we are in Q0 and we encounter B, go to Q21. Right, Q21. So this was Q0, and you encounter a B, 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 B. So it's Q2, not Q21. It's Q2, not Q21. There we go. Q0 and you read a B. Go to Q2. Right? Then if you're in Q2 and you read another B, stay in Q2. Read another B, stay in Q2. Right, so this is the, right. So if you're in Q1, your output is 1. If you're in Q2, your output is 0. This one is 0. Then the triple B, if you're in Q2 and you encounter B, Q2, you encounter B, Q2 and you encounter B, of course, test 0. Q2 and you encounter B, and Q2 is doing Q2 here, so it's here. Right. So, okay, so just hold on. So we said Q1, we go to Q1 with an A, go to Q0. Q0 with an A, okay, if in Q0 you indicate an A, go to Q1. In Q1 and you get a B, get to Q2. If you are in Q2 to 1 and you get an A, you go to Q0. Then P2 P2 Q naught Q2 state Q2 if in Q2 and you region O is 0, Q2 190 or Q0. So we've got Q naught engine counter in A, go to Q1. Then, okay, so let's just redo this one. I'm seeing something there. Seeing something. So we said we've got our table. We've got input, states, and output. The input is there. So we shade this, we've got A, B, B. Right. When it is in state Q naught, it is with an output of 0. When it is in state Q1, there is an output of 1. When it is in state of Q1, and you encounter B, go to Q21. Right. Q21, and you encounter A. Encounter A, go to Q naught. And then if you are in Q naught and you encounter B, if you're in Q naught and you encounter B, we are going to have Q naught encounter B, you're going to have Q2. If Q2 is going to round another B, you've got so in Q2 and you encounter B, you stay in Q2. And the B. Right, so Q naught is an output of 0, Q1 is an output of 1, Q2 with an 8 goes to Q naught, and Q21, we've got an output of not here, Q naught, we've an output of not Q2, an output of B. So here we've got, so we said with Q2 and you encounter B, you go to Q21. There we go. And then if you're in Q21 and you encounter B, stay there. So I said if you're in Q21 and you encounter B, you stay in Q21. Right, so we've got 0 Q naught, Q1 is 1, Q2 1 is 0, then A, Q naught is 0, Q2 is B, then here we're saying Q21, what is Q21? It's 0, then we've got Q12 or Q21, that is 0 as well. So Q naught, then B, right? So Q naught, when you delete a B, you go to Q and 2. So Q naught and you delete a B, go to Q2. At Q2 and you read a B, you go to Q naught and you read a B. If you're in Q naught and you read a B, you say what you do. And read a B, go to Q21. If you're in Q21 and you read a B, go to Q12. And then so that's fine. So we need to go to Q21 over here. Q21. So this becomes the summary table output of machine. Right. Now, let's move on to a Moore machine. We want to find what's the output of this string. The output of this string is given as below. Output, we draw our input table. So we said we've got input, state, output. So we've got this shaded out. We've got to A, B, B, B. A, B, B. A and 3 B's, A and 4 B's. And so we've got a long one, A, 4 B's, A, 3 B's. So A, B, B. We've got A, B, B. We need to take another A. Then you've got A, B. Then we've got B, A, B. So we're just going to try and find the correct one from this. So it starts at Q naught. Then the output is 1. Then you go to 0. 0, Q naught, and you encounter A. And A, you go to Q2. Then on count of 0. B, if you're in Q, if you have got a B, so Q naught with a 1, output of 1 with an A takes you to Q1. Right. Now, Q1 with a B, Q1 with a B goes to Q2. Q2 with a B, you go to A. You go to Q naught 1. Q naught 1. Q3. Oh, we've got Q1. Throwing a B. Right, so we want to have Q. So with Q naught, it gave us Q1. Q1 gave us Q2. Q2 gave us Q3. Within A, Q2 gives us 0, Q3 into Q3. If you are in Q3 and you encounter B, and you go to stay in Q2. Then, if you're in Q2 and you encounter B, so let's pause a minute. Q2 and you encounter B. Over here it's at Q1. Just a second. So we said Q0 encounter. In Q0 is state 1. If Q0 encountered A, you go to Q1. And that output is 1. Sorry. Then Q1 and you encounter B. Q and you encounter A. If you're in Q1 and you encounter B, where do you go to? Go to Q2. Q1 and you encounter B. We have to go to Q2. If you have got that, right, this looks jumbled up. Let's just redo it. Input. States and output. Closed A, B, B, A, B, B, A, B. That's Q0, output of 1. Q0 in A, you go to Q1, 1. Q1 engine counter in A, Q1 engine counter B, go to A2. Right. So 9 Q1 engine counter in B, Q1 in counter B, go to Q2. Right. Q2 is with an output of 0. Then Q2 in the B stays there. So it stays there with the, so Q2 with the B, it stays there. So it's staying in Q2. Q2 with the B, we're saying it goes to Q2. So it's Q2, and then it is 2, 0. But then A, you then leave, go to Q0. The term is 1. Then from Q0 if encounter B, go to Q1. Q1, Q0, Q, if you have a B, go to Q1. Q1 is with an output of 1. If you're going to, from Q1, if you encounter B, from Q1, if you encounter B, you go to Q2 with a 0. And then Q2, and you encounter an A, you go to Q0 with a 1. Then B, when you encounter Q0, you go to Q1 with a 1. So you try and find the correct one. 00, or 11, 00, 11, 0, 1, 1. Right. So let's just go through it again. Q0 and you encounter 1. Q0 you encounter an A. So I've got A triple B here. It should be A I have A double B. This should be A triple B. I should have another column in between. Let's see what I should have. So I'm on Q2, and you encounter another B. So you stay in Q2. It should be a 0 over there. Then you can proceed. So it's 1 1 3 zeros 1 1 0 1. So it should be option 3. All right. Cool. So let's take a pause there. Right. Then we can do the other finite automata with output machine in our next class. And that will be on Wednesday. So thank you very much for attending. Enjoy the rest of your evening. Good night.